You guys just a little bit of background, and then we'll dig in more detail. We have a view, I don't think it's a unique view, we have a view that the web is becoming, you could argue has become, a visual first web. So it's a web that is about where consumer satisfaction online is increasingly based on rich, interactive, visual experiences. And so if you look at like Pew research on that topic, they're saying about 2 billion people actively posting photos and videos online. But maybe a more interesting statistic is that 950 million actively curating photos online. So 950 million, almost 1 billion people are playing around with other people's content. They're liking, posting, tweeting, pinning, sharing other people's content. And the challenge is, from our perspective, that there is a kind of a gap between the sort of richness and expressivity that we have when we think about images, when we interact with images, and what computers actually know about images. So what computers know about images, they acquire during like crawls from text that they can mine near the image. But what humans know about image, we look at an image, right? We see all this meaning, all these layers of meaning. And that gap is a real inhibitor to growth in the visual world. In order for us to see the kinds of applications I think that that consumers want to see, we've got to find some way to fill in the gap between what the image says to us as a human being versus what it says to the computer in terms of the available data that a computer can use to interpret and reason on that image. So at Tagosaurus, we've been thinking about this idea of building a whole new data layer of context and interpretation for visual content on the web. So that sort of seems like a ridiculously large problem to solve, but it seems to us, in order for us to ever realize the sort of power and value of our content, we've got to find a way to make it more expressive. We've got to find some way to sort of jack meaning into it and do it in a way that is computational, do it in a way that is computable. So search is an obvious example. There's others we'll talk more about. So we built this web service. So the web service is, we think of it as a human-assisted computing platform. So what the heck is that? So human-assisted computing platform is we tap into crowds. So we talked about 1 billion people online. We tap into crowds, and we tap into computer intelligence, and we try to combine those two things synergistically in a way that enables them to work together cooperatively such that the output is better than either constituency could produce in isolation. So that's this idea of humans and computers working together. So that's the first part of what we did. And that crowd is really a remarkable thing. I'll show you in a few minutes just the scale at which you can do things as a result of those crowds. So that's the first thing. The second thing is we talk about smarter tags. So everyone knows what a tag is. If I say a tag, we all get hashtags, we all get what a tag is. But actually, there's a lot of disinformation about what a tag is, or a lot of misinformation about what a tag is. A tag can be a text string that just is woman, for example, but a tag can also be what's called an entity. An entity has a couple parts. It has a label, like Paris, the city in France. It has maybe an image that represents it, or images, a gallery potentially even of images. It has a HTTP URI, a unique identifier, and it can have a whole payload of information about what that thing is, what Paris is a geoplace, when it was founded, what rivers run through it, what the population is, the land mass, And so when we think of a tag, we think of a singular person, place, or thing, or potentially an event, online that has those kinds of properties. It has data about it. It has a link. It has representative visual exemplars to define it. And if you think about that, where we derive those tags from, we call it background knowledge, but it's things like Wikipedia, things like geonames, things like the International Taxonomic Information System. These are data repositories that are out on the web, and we mine background data from these sources, and we put it together in a structure that's like a graph. It's a structure that computers can reason across. So I'll give you an example, and then we'll move on from tags. In a traditional business environment, if you think about, I have a picture of Barack Obama, I have a keyword annotation department, and I'm going to tag that image. The picture of Barack Obama, I need the taggers to say man, then they probably put a synonym in, they say male, and then they'll say leadership, president at the moment, then they'll say his maybe stage of life and something about what he's doing. Is all this sort of redundant data. Next image, same exact thing. In our system, we just need one tag, Barack Obama, and we connect that to all the background knowledge we've accumulated from Barack Obama from sources like Wikipedia. We don't need to know that he's the president, that he was a congressman, what newspapers endorsed him, the name of his dog, his wife, kids, his current domicile or residence. We know all that already. That's collective intelligence. So we're using the web as a content, kind of a giant content management system, a knowledge base. And the process of tagging for us is about connecting these images to that background knowledge in a way that allows computers to extract more value and more meaning from it. So that's the second part of the system. The third part of the system, I talked about crowdsourcing, wisdom of crowds. This idea that we connect to, have the kind of an agnostic view of where the labor comes from. Most of us that have DAMs think in terms of a curation staff or editorial staff or tagging staff, keywording staff, whose job is to input to that DAM. Our view is try to build like a hybrid model that makes use of those experts, those subject experts, but also frees them from the drudgery of saying man, woman, indoors, outdoors, day and night, this kind of repetitive thing that goes on and over and over again. And so we connect into a variety of different labor environments. So one of the examples of that is Mechanical Turk at Amazon. We plug into the Amazon Mechanical Turk marketplace, and we're able to bring thousands of workers to projects instantaneously. So this idea of elasticity, we can just bring human intelligence to bear on a problem on demand. So that's a big deal. The other thing that's cool about those crowds is we can use them for data verification. So yes, we use them to sort of human judgment and interpretation to make the data more rich. I would also say an advantage of crowds is plurality. If you look at an image and I look at an image, we both see something different. If you crowdsource, you have multiple eyes on it, then you capture that broader perspective. And then we use humans to verify that data. And then, come around here, we try to learn computationally from what's happening. We try to train computer vision systems. We try to train text extraction systems or systems that identify and recognize context. And we try to do that all as a continuous learning loop. So you think about tagging, it's like, as we think about it today, it's like Gutenberg, the extension of the printing press, right? It's this thing that happens on the way to making a product, on the way to distributing a product. We think about it as a continuous improvement system. We think about it as a system. So the moment Barack Obama's not president anymore, or the moment Margaret Thatcher dies, we want the system to update. We want the entire knowledge base to update. So we think about this as a living, dynamic system. So I talked a little bit about scale. This is a single customer account. They were running 250,000 tasks in our system. There's a number of these accounts. This is like a multi-user, cloud-based software as a service solution. Almost 20,000 active workers, producing sort of 30, at the peak here on this graph, 35,000 tasks in a day. So that's on the scale of almost 250,000 images processed in a day. So tasks for us is not like tag an image, it's maybe tag 5 images or look at 30 images. But you're talking about the ability to process hundreds of thousands of objects in a day. And I can show you graphs where people were processing nothing, and the next day they've got 50,000 tasks done, and that gets done, and then it's off. They didn't have to stack all that stuff up. They didn't have to hire the workers, train the workers, buy the computers, buy the desks, put the people in the desks, and then fire them all the next day and then do it again. So this is this idea of elasticity. We hear about that in cloud computing, that we can dial in compute capacity and demand. We kind of bring that together with crowd computing so that you get the ability to dial in human intelligence along with computational capabilities on demand. So that's the sort of second part. The other thing is, we're working hard to try to enable people to apply this to highly specialized collections. So the challenge with crowdsourcing is domain expertise. Where's the guy that knows about architecture and knows what Housemania is? Or where's the person that knows about the taxonomic information system or about fashion or food? Is a very challenging thing to deconstruct after it's cooked. For example, it's hard to know how to describe food after it's made. So we have worked really hard to try to build processes, and there's more work to do, but to try to build processes that enable us to really serve highly specialized domains with generalized labor. And so we've got these kinds of hybrid models of crowds and niche sourcing where we attract experts. We did a big project with the National Endowment for the Humanities here in New York with the Museum of the City of New York, where we mined followers off their Facebook and Twitter page who had expert knowledge about art and architecture in the history of New York, and were able to find and identify what they called mystery pictures. They had pictures with no identifying information in their collection, and they wanted to say, where is this in New York? And they were able to answer that. And what was interesting about that is it became the #1 driver of traffic to the museum website, where people that were interested in the mystery picture problem. So what was a business problem now became a business opportunity, and the whole thing turned on its head. And that's sort of the theme of this talk, is turning this entire thing upside down and thinking about it in a new way. So that is this idea of both combining crowdsourcing with your own internal expertise and niche expertise that you can mine intelligently from the web. So we use all this data that we collect to sort of light up search, and these are some of the things that we've been working on in partnership with folks. We really like partnerships because this is still new territory. But folks like Magnum Photos, the New York Times, Trunk Archive, the Rogers Archive, Vivian Maier, you've heard about this in the news, it's been in the theaters, the Museum of the City of New York. These are just a sort of sub-sampling of customers. But in each of these cases, we're trying to help people deliver some sort of more expressive search experience. So, it's a mobile web, it's a visual web. We know that people don't search on mobile devices, they browse. Consumption patterns are different, information seeking patterns are changing. Is search the end of the line? And I think that the idea behind metadata so far is that sort of search is the end of the line, but for us, search isn't the end of the line. Because beyond search is this idea of discovery. And for us, discovery is this concept about relatedness and the connectivity of things. And what we really want, the reason we're really interested in these giant background data sets, is they allow us to take an image or take a fragment of video and interconnect by content, context, provenance, usage, all of the related ideas. So I'll give you an example. This is an image that was in the Washington Post. It was from the 125th anniversary of the Eiffel Tower. It was on a page. It was indexed by Google. People were browsing to it. But that's all there was. There was an article. There was nothing. If I was interested in this topic, there was nowhere for me to go. Nothing for me to do. I couldn't click on the image. I couldn't find anything else about the image. I could just read the article and then go back to Google and search again. So with this graph database, we just did an experiment. We said, what if we used this image and the identifying data we had for it, which was like Paris, 1889, Library of Congress, or something like that. That was all the identifying data they had. What if we use this as a query? If we use the image as a seed document, what could we do? And so we queried our database, and what we found were all these related concepts automatically. So let's talk about those for just a minute. So we have an image of the Eiffel Tower. We know that this guy was one of the architects that worked on that. This guy, by the way, he also worked on that. That's the tallest building in France. This was the tallest building in France. The tallest building in Paris, excuse me. This was the tallest building. Worked on that. This is another famous tower. It happens to appear, the fair took place historically on the Champ de Mars. This is an image from the same period, 1889. It was part of the Paris Expo. We know that. We know its geolocation. We know all these facts about it. And we know all these other articles that appeared in the Washington Post that were related to it. And we know that automatically. And this is sort of the part that's getting us, that we feel like begins to suggest what could be, right? This ability to reason on visual content and use those reasoning operations to create more expressive user experiences. And so this is a not so much I think more of an expression of what we think can be. So a service like Flipboard is an amazingly cool service, but it's just sort of this time linear experience. I can't get out of that. I can't discover from that. I have to get out of that magazine and go find another magazine and then browse from there. So our sense is sort of take the intelligence out of the page and put the intelligence in the asset. And we think this is where the web is headed. This is where it's going with video fragments, with the WC3 media fragments URI. This is where it's going with images. And so the challenge for all you guys to think about is, do you have the classes of metadata that can support that experience? And can you do this with text strings? So we don't think you can do it with text strings. We think Google has already thrown in the towel in 2009 on text strings. We think that Facebook threw in the towel with graph search on text strings. We think you have to use graphs. So you think about the knowledge graph, you think about Open Graph. Those are all graph-based representations of knowledge. And that's exactly what we're describing here. A way of taking something like the Eiffel Tower and representing it structurally and semantically and computationally in a way that lets not only us interact with it as human beings, but lets machines reason on it in an automated way. So you say, well, why is that important? But you look at an organization like the BBC, it's the world's largest broadcaster. As I understand it, 80% of their traffic comes from search engine crawlers, from bots. And so that's a huge, that's their biggest information consumer is a bot. And I think that's what's going to happen with digital archives, that we're going to increasingly have APIs, crawlers, machine-mediated access. And so we need to start to think about how do these siloed systems play in a world where connectivity is ubiquitous. We are living in an age now where the web is ubiquitous, connectivity is ubiquitous. What is the, so I look at dams as sort of these silos in this world of otherwise highly interconnected audiovisual experiences. And I think for you guys, visual asset owners, visual asset syndicators, I think a real challenge for you to reflect on is the kid with a cell phone now, in some ways, has better access to market than you do through your dam. Because he puts this thing on Facebook, it's immediately discovered by all his friends, all the people that are following him. You see how, we've all been to trade shows where we see how images propagate on Flickr and Twitter and Facebook, where there's this social engagement, and all of a sudden there's a bazillion people following it, and it goes viral. That doesn't happen traditionally with dams. Doesn't traditionally. So this idea of kind of making your content accessible in a responsible way, in a way that protects the copyright, protects the provenance, protects the image, but also makes it accessible. And that's where we think this kind of technology makes the difference. So data-driven experiences is a keynote. And then, sort of my closing slide. I mean, it's a very short talk, but my closing slide just is this sort of challenge. If you think your content is valuable, I think you really need to start to think about what a tag is, what a keyword is, what metadata is, and what the future looks like. And that's just something to reflect on. And with that, I open it up to questions, if you have any, and if not, then have a fantastic show and enjoy the day.